When the number of objects becomes large, it is helpful to think of them in groupings rather than as individual objects. This reduces the total number of objects that we have to consider. Example, use a grid to compute 50 divided by 10. If we were to try to draw out this grid using individual boxes, this would take a while. Instead of drawing out 10 individual boxes, we can draw a cluster that represents 10 boxes. This is a far more efficient way to go, and we can quickly see that this gives us 5 groups. So 50 divided by 10 is equal to 5. What we've done is actually treat the group of 10 boxes as a single object. We will look at this from another perspective in the next example. Example, use a grid to compute 120 divided by 30. Instead of drawing out individual boxes, we will once again use clusters of 10 boxes. Notice that counting out 3 groups of 10 is much more efficient than counting out 30 individual objects. So 120 divided by 30 is equal to 4. Instead of making groups of size 30, we're really only making groups of size 3. And instead of 120 total objects, we're really only working with 12 objects. Let's pretend that the boxes represent a tangible object like a pencil. You have 120 pencils and you're trying to make groups of 30. Instead of counting out groups of 30, what you can do is you can start off by making groups of 10 and bundling those together with a rubber band. If you did this, how many bundles of 10 would you make before you ran out of pencils? 120 pencils bundled into groups of 10 pencils will leave you with 12 bundles. And now that we have our bundles of 10 pencils each, how many bundles will we need to have 30 pencils? We only need 3 bundles. So if we take our 12 bundles and make groups of 3 bundles each, we will have 4 groups of bundles. This works because 3 bundles of 10 pencils each has 30 total pencils in them. What we are doing here turns out to be the same thing that happens when we reduce fractions, but that's getting ahead of ourselves. For now, we just want to focus on the division itself. Example, compute 120 divided by 30. This time we are going to express the process symbolically. Recall that we took the problem 120 divided by 30, and by putting things into bundles of 10, turned it into 12 divided by 3. 120 divided by 30 is the same as 12 divided by 3. And from here we can do the calculation 12 divided by 3, which gives us 4. As we look at this problem symbolically, what we are doing is we're canceling out zeros at the end of both of these numbers. As long as we cancel out the same number of zeros in both the divisor and the dividend, our calculation will be valid. But it is important to always keep in mind that what we are doing is regrouping the information that has been given to us into a more convenient form. Example, compute 800 divided by 20. When we make bundles of 10, the 800 individual elements become 80 bundles, and the 20 individual elements become 2 bundles. So this problem changes from 800 divided by 20 into 80 divided by 2. Notice that we've removed the same number of zeros from both the dividend and the divisor. And then 80 divided by 2 is a calculation we can do. Gives us 40. Make sure that you cancel out the same number of zeros from each part. Do not just eliminate all the zeros because that will be wrong. Example, compute 120,000 divided by 300. How many zeros can we cancel out from each of these values? We see that the divisor has 2 zeros, and the dividend has at least 2 zeros, so we can cancel out exactly 2 of them. This gives us 1,200 divided by 3, which is 400. Symbolically, this is very simple. Conceptually, all that's going on is that instead of making bundles of 10, we're making bundles of 100. This means that instead of trying to count out 300 individual objects, we're only counting out 3 bundles of 100.